Hi, my name is Patrick Reagan. Welcome to the Storage Devices series of videos where we'll go in depth of the storage drives used in your computer, including hard drives, SSD drives, RAID, and removable storage. This video is Storage Devices Part 3, Solid State Drive and SSD Interfaces, which covers the characteristics of solid state drives, non-volatile memory express drives, and the M2 and mSATA form factor. It also covers how to install the M2 SSD drive. For those who are going to take the A+ exam, there are practice questions toward the end of the video. Newer style drives are solid-state devices, or SSD, which uses NAND flash memory. Compared to the legacy hard drives, the SSDs are lighter and smaller. All electronics, no mechanical or moving parts. Since no moving parts, they are not high-failure items and are shock resistant compared to mechanical hard drives. In addition, since they consist of flash memory, they are faster and consume less power than the mechanical versions. How long the SSDs last depends on how often you write data to it. Today, SSD form factors include the Mini Serial Advanced Technology Attachment, or mSATA, which can support only the SATA interface, and the M2, which can support both SATA and PCI Express interfaces. If you need the highest possible speeds and have a system that supports it, an M2 SSD is the better choice as it can take advantage of PCI Express, which is a much faster interface compared to SATA. mSATA, or Mini SATA, is essentially a smaller version of the full-size SATA SSD, which is shown in the right corner. This form factor is designed for smaller form factor systems where space is limited. mSATA slot width is 30 mm, which matches the 29.85 mm width of the mSATA card. M2 refers to the form factor. Most SSDs are 22 by 80 mm, but can be shorter or longer. M2 drives can have one of the following interfaces: Advanced Host Controller Interface, or AHCI, which is used to communicate with the serial ATA SATA devices, and Non-volatile Memory Express, which runs on PCI Express, which is much faster than SATA interface. Here are common M2 SSD sizes, ranging from 22 by 30 mm to 22 by 110 mm. Keys or notches are to ensure that the device gets connected to the correct slot. Currently, an M2 SSD has either one of the three key types. B uses PCI Express up to 2 by lanes and up to 2 GB per second bandwidth performance. M uses PCI Express up to 4 by lanes and up to 4 GB per second performance. B plus M maximizes compatibility at both slots, but will only operate at 2 by lanes. More lanes a PCI Express slot uses, the more bandwidth you have. If you want the fastest speed, make sure to use the M2 M key, which has 4 by PCI lanes. Non-volatile Memory Express is a high-performance, scalable, and standardized interface protocol designed specifically for accessing non-volatile storage media, typically flash-based SSDs, over a PCI Express bus. Features include interface protocol designed to replace older storage protocols like SATA and AHCI for SSDs, higher input-output operations per second or IOPS and throughput, has much lower latency than SATA and SAS SSDs, supports up to 64,000 queues, each with up to 64,000 commands compared to AHCI single queue with 32 commands, and commonly used in M2 form factor. Here's a table comparing mSATA versus M2. As you can see, mSATA is the obsolete version of SSDs that only runs up to approximately 600 megabytes per second, while the M2 can access the PCI Express interface that goes up to approximately 3,500 megabytes per second and 7,400 megabytes per second for PCI 4.0 using 4 lanes and probably higher in future versions. Here is a table of the current PCI Express generations. As you can see, the next generation PCI Express 5.0 by 4 lanes can go up to 14,000 megabytes per second. To remove an SSD drive, you just unscrew the holding screw and pull out the drive at an angle. To install the drive, insert the drive into an angle and tighten the holding screw. Sectors are used primarily as logical addressing unit for the sake of the operating system being logical block addressing, or LBA. SSDs do not write data directly to the physical sector like hard drives. Instead, they use a flash translation layer, or FTL, to map logical sector addresses to physical locations in the NAND flash memory. This mapping is dynamic to support wear leveling and garbage collection where sectors are moved around to prolong the life of the storage cells. Internally, SSDs organize data as SSDs generally use sectors that are 4096 bytes in size, although older SSDs and some legacy systems might still use 512 byte sectors. Pages, for example 4 kilobytes to 16 kilobytes, are the smallest unit that can be read or written. Blocks are 128 to 512 pages, which is the smallest unit that can be erased. By having the larger 4K sectors, the sectors are more efficient because each sector stores metadata for the entire chunk of storage, which reduces overhead needed per byte of data, increasing usable space and performance. Most modern file systems use 4K clusters by default, which matches the OS's cluster size, reducing misalignment and unnecessary reads and writes. By having larger sectors, you have less writing, which increases lifespan of SSDs. In addition, 4K sectors allow stronger ECC, or error correcting code, which enhances reliability, especially on flash memory, and since ECC space is larger per sector in 4K, it improves data integrity. SSDs are generally considered more reliable than traditional hard drives, particularly in daily use and mobile applications. While SSDs are generally more reliable than HDDs, they do have a limited number of write cycles, meaning the drive can wear out over time with extensive writing. SSDs employ wear leveling and garbage collection techniques to distribute writes across different memory cells, extending their lifespan and improving performance. Static wear leveling moves rarely changed data, such as operating system files, from low wear cells to higher wear cells periodically. Dynamic wear leveling is new data is always written to the least used blocks and constantly tracks usage and avoids rewriting to the same cells repeatedly. Factors like NAND flash technology, such as SLC, MLC, and TLC, and temperature can also impact their longevity. As you can see from the table, SLC is the fastest and most durable, but would also cost the most, but with MLC and TLC being more mainstream. Terabytes written, or TBW, in SSDs refers to the total amount of data a drive can write before it starts to wear out or fail, and it's a key indicator of the drive's endurance and lifespan. Essentially, it tells you how much data you can write to the SSD before you might need to replace it. Once the TBW limit is reached, the SSD may become read-only or start to fail gradually. SSDs mitigate per cell limits by using wear leveling and over-provisioning. Over-provisioning in SSDs refers to reserving a portion of the total NAND flash that is not accessible to the user in order to improve performance, endurance, and reliability. To check your SSD's TBW, you can use the utility shown on the screen, or you can use the sudo smart CTL command also shown on the screen in Linux. You can expect a modern SSD to last between 5 to 10 years depending on how it's used. SSDs can have high MTBF values. This doesn't necessarily translate to a long lifespan if the drive is used heavily with frequent writes. Question. Today, what are the two form factors used for SSD drives? Answer: M2 and mSATA. Question. Which M2 provides the fastest performance? Answer: M. Question. You're asked to set up a new laptop for a coworker. Which of the following storage devices and interfaces provide the best performance? Choose two answers. Answers: M2 SSD and Non-volatile Memory Express or NVMe interface. Question. You're upgrading a user's laptop from an HDD to an SSD. The user's laptop only has a single bay for a hard drive. Which of the following characteristics of the SSD is the most important in this scenario? Answer: form factor. Question. Logical device interface used for accessing non-volatile memory storage devices attached via PCI Express is known as what? Answer: Non-volatile Memory Express or NVMe. Question. Which of the following dedicated expansion slots or ports on the PC motherboard enables a connected on M2 device? Select all that apply. Answers: B key slot, M key slot, and B plus M key slot. Question. Which M2 key type allows an SSD to use 4 PCI Express lanes for maximum performance? Answer: M key. Match the key to the description. B key is used for SATA SSDs or slower PCI Express drives, but only by 2 speed. M key is PCI Express by 4 lanes, non-volatile memory express. B plus M key is compatible with either SATA or PCI Express, but only at by 2 speed. Question. What does 2280 refer to when discussing an M2 SSD? Answer: 22 millimeters wide, 80 millimeters long. For more information, refer to these sites. In summary, newer style drives are solid-state devices or SSD, which uses NAND flash memory. Today, SSD form factors include Mini Serial Advanced Technology Attachment, or mSATA, and M2. If you need the highest possible speeds and have a system that supports it, an M2 SSD is the better choice as it can take advantage of PCI Express, which is a much faster interface compared to SATA. mSATA, or Mini SATA, is essentially a smaller version of the full-size SATA SSD. Currently, an M2 SSD has one of the three key types, B, M, and B plus M. If you want the fastest speed, make sure to use the M2 M key, which has 4 PCI lanes. Non-volatile Memory Express, or NVMe, is a high-performance, scalable, and standardized interface protocol designed specifically for accessing non-volatile storage media, typically flash-based SSDs, over a PCI Express bus. While SSDs are generally more reliable than HDDs, they do have a limited number of write cycles, meaning the drive can wear out over time with extensive writing. SSDs employ wear leveling and garbage collection techniques to distribute writes across different memory cells, extending their lifespan and improving performance. Terabytes written, or TBW, in SSDs refers to the total amount of data a drive can write before it starts to wear out or fail, and it's a key indicator of the drive's endurance and lifespan. Thank you for watching this video. The next video will be Storage Devices, Part 4, Removable Drives and External Drives. If you have not already, subscribe to the Pat Has Your Back channel. Thank you.